Hello everyone. Today shall discuss about oscillations, that is class 11, physics and chapter number 13. This is for Cbse Ncert curriculum aligned. Now we'll discuss about oscillations, what are the different features of oscillations and how it works. Introduction to oscillatory motion. Motion that repeats itself to and fro about a mean position is called as oscillatory motion. Here you can say, for example, playground swing, it is an oscillation. Vibrating string in guitar, that is also a type of oscillatory motions. The pendulum clock, this is also a oscillatory motion. Or the engine piston, this is also examples of oscillatory motions. Periodic motion. There is difference between periodic motion and oscillations and simple harmonic motion. What is periodic motion? Motion that repeats at regular intervals of time, that is known as periodic motion. Key distinction: periodic but not oscillatory. For example, Earth is orbiting the Sun, repeats but no to and fro movement. So this is a periodic motion but not oscillatory. Periodic and oscillatory. Mass on spring repeats and moves back and forth through a center point. Therefore, it is not only periodic but also oscillatory motion. You see the child's height like this, right? And this is ball's height. The ball is dropping in this way, in this way, in this way, like this. So these are various examples of periodic motions and oscillatory motions. You see, defining oscillation. These are the extreme position and this is the mean or equilibrium position. At equilibrium position, the net force is equal to 0. This is the oscillatory path. It is oscillating in this way. So this point and this point is known as extreme position and this is the mean position. You can see that the kinetic energy or the velocity at the extreme position is 0 and the velocity at the mean position is maximum. Or you can say the acceleration at the extreme position is maximum but the potential energy, or you can say the possible potential energy at the extreme point is maximum. You can say, or you can say that this is the mean position. So this is extreme position, this is mean position. At extreme position velocity is 0, at mean position velocity is maximum. In case of if we take the acceleration, then you can find that the acceleration at the extreme position is maximum and acceleration at the mean position is 0, right? In this way you can say that here at the mean position the net force is also 0, right? So you can find this type of oscillations as oscillatory motions. Important terms and symbols. Displacement x, distance from the mean position is termed as displacement, or that is x. Amplitude, magnitude of maximum, you can see here this is the maximum displacement. So this is the amplitude of the periodic motion. Time period, time taken for one complete cycle of, or unit is second, that is time period. Frequency, number of oscillations per second is known as frequency and unit is hertz. Angular frequency omega equal to 2 pi by t and unit is radian per second because 2 pi is in radian and time is in second. So these are the important terms of periodic and simple harmonic motion. Simple harmonic motion, what is that? The simplest form of oscillatory motion. The condition, the particle oscillates about a mean position under a restoring force directed towards the center. The restoring force is always directed towards the center. You can see here that it is directed towards the center only. You see, this is the suppose if we take this as mean position, take this mean position, this one as the mean position, then see the displacement is in this direction, compressed, but the force is acting in this direction. So we can say that F is equal to directly proportional to that of minus x. Force is directly proportional to minus of x because the force and displacement x is in opposite direction. Or you can write F equal to minus kx, that is the equation for a simple harmonic motion. Or if we write F equal to m into a according to Newton's second law of motion, then it can be written as minus kx, or acceleration can be written as minus k by m into x. Or if you write this as acceleration as minus omega square x, Therefore, omega is equal to, we get the value of root over k by m, k by m. This is the angular frequency of this spring mass system. So this is the simple harmonic motion, and this is the one of the condition that this f equal to minus x. Or you can write acceleration in terms of like this d square. Acceleration, you know that acceleration equal to dv by dt, right? dv by dt. If we change it into like this, that a is equal to ddt of velocity. Velocity is what? Dx by dt. Dx by dt. That means it will be different double differentiation. If we differentiate with again, then it will be d square x by dt square. Right? D square x by dt square. So this is acceleration. So in terms of acceleration, we can write here as d square x by dt square is equal, is equal to minus omega square x. Therefore, it can be written as d square x by dt square plus omega square x equal to 0. And this is the differential equation for simple harmonic motion. This equation is known as differential equation, known as differential equation of simple harmonic motion. So these are the various important things in simple harmonic motion. So you have to remember that the d square x dt square plus omega square x is equal to 0 is the differential equation for simple harmonic motion. Now you find that mathematical condition. I already told you that ft is equal to minus k into x, and this force is dependent on time. Right, here you see when the displacement is in this direction, the force is in this direction, so they are in opposite in direction. So f is equal directly proportional to minus x, or you can write f equal to kx. So the negative sign force opposes displacement. Displacement x is the displacement from mean position, right? So you can find that f is directly proportional to minus x is the condition for simple harmonic motion. And what is k? K is known as the force constant. K is known as the force constant. So force constant is k, right? So this is a constant, and it is known as force constant, and F is the restoring force. And find that the equation of SHM. The equation of SHM can be found out by this xt is equal to a cos omega t plus phi. So this x, the displacement of x is dependent on time, right? Now what you get here is the equation of SHM x equal to a cos omega t plus phi, where xt is the displacement at time t, a is amplitude, maximum displacement, that is amplitude, omega t plus phi is the phase or current state of motion, and phi is the phase constant or initial phase at time t is equal to 0, that is the phase constant. Here you find the displacement xt, this one is the displacement xt from 0 position, from here to here, right? So this is the this is called it as, if we start the, so this is the equation of simple harmonic motion. So these are the various terms we already explained. That displacement is amplitude, omega t plus phi is the phase or current state of motion, and phi is the phase constant or initial phase at time t is equal to 0. So this is the equation of simple harmonic motion. Now you see the velocity in simple harmonic motion. How to get the velocity? You see velocity is the derivative of displacement. So what we get, that xt, we get the value of xt is equal to a cos omega t plus phi. And if we want to find the velocity, then we get the dx dt. Velocity, you know that velocity is equal to differentiation of velocity is also the function of time. So velocity equal to dx by dt. And if we differentiate this equation, cosine will be changed as minus sine, minus omega a sine omega t plus phi, sine omega t plus phi. This is the velocity, right? Or in terms of, if we want to find in terms of position, then you can find v as omega root over a square minus x square. How we are getting this value? See here, we get minus omega a sin omega t plus phi, right? A sin omega t plus phi. So this is the velocity, right? If in terms of position, equal to omega root over a square minus x square, right? So what we are getting, that velocity is equal to omega root over a square minus x square, and I put the value of x as a cos omega t, then we are getting the value omega into root over a square minus x square means a square cos square omega t plus phi, right? This is omega t plus phi. So if you write in this way, then you get the omega root over, if we take the common as a square, then we are getting 1 minus cos square omega t plus phi, right? So we are getting the value here as omega root over, that is a square sin square omega t plus phi. So again we are getting the same value as omega a sin omega t plus phi, that is the omega a sin omega t plus phi. This is actually the value, right? So in case of velocity, we are getting so these are the equation, the velocity minus omega a sin omega t plus phi, you are getting the same value here also. In terms of position, equal to omega root over a square minus x square. Maximum velocity, you know, maximum velocity at mean position. So the maximum velocity will be the value of, we know that the value of sin omega t plus phi is 1 maximum value. So v equal to minus omega a is the maximum velocity. And minimum velocity at x equal to plus minus a. Minimum velocity plus minus a, that is velocity equal to 0, and 0 at the example here, see the 0 is at the the velocity is 0, the velocity is 0 at plus minus a, right? So here creating this is the maximum velocity omega a, right? This is the maximum velocity, and minimum velocity is 0, right? So at this position and this position, you are getting the value of plus omega a, and this is minus omega a, right? So these are the various terms of SHM according to velocity. So the maximum velocity at the mean position and minimum velocity at the extreme position, the velocity is 0 at the extreme position, right? So we are getting the graph like this, right? So this is the expression for velocity, right? Now we'll get another important term, that is acceleration in simple harmonic motion. What in case of acceleration, what we get here is, see that acceleration is the derivative of velocity. So for acceleration minus omega square a cos omega t plus phi, relation a t is equal to minus omega square x is a cos omega t plus phi. So maximum acceleration at extreme, we know that the value of maximum value of cos theta is 1. So the maximum acceleration at extreme value is equal to omega square a. Zero acceleration at mean position, and maximum acceleration at the extreme position. So here is the velocity, acceleration displacement graph. You see here at this is the maximum acceleration omega square a, right? This is 0 at mean position. Acceleration is 0 at the mean position, and again maximum at the extreme position, that is minus omega square a. This is plus omega square a, right? So in this way we find the value of acceleration. So this is the acceleration in simple harmonic motion, right? So what you get, maximum acceleration at extremes value is omega square a, and 0 acceleration at mean position. The mean position, the acceleration is 0. And what you find here, displacement time graph. This is the displacement time graph. So this is t by 4, this is t by 2, this is 3t by 4, this is time. So this is the displacement time graph, right? If you find, this is the graph of displacement time graph, and if you find velocity time graph is like that, t by 4, t by 2, 3t by 4, and t. This is velocity graph is also sinusoidal. phase difference, velocity leads displacement by pi by 2 or 90 degree. What observation we get? This is displacement versus time, and this is velocity versus time. Observation when displacement is maximum, velocity v is 0. We found this also. And this is acceleration time graph. This is acceleration. Acceleration graph is a mirror image of displacement, right? Acceleration graph is a mirror image of displacement. Phase difference. Acceleration is out of phase with displacement by pi or 180 degree. Where x is plus a, maximum positive, a is minus omega square a, maximum negative. So you get all these graph also. Energy in simple harmonic motion, kinetic energy due to motion is half m omega square a square minus x square. And potential energy, stored energy due to position is u half k x square. And total energy, constant of sum kinetic energy plus potential energy, that is k plus u, that is half k square. Total energy depends on amplitude squared only, right? Total energy depends on amplitude squared only. So the total energy is constant, but kinetic energy and potential energy is variable at different points. And this is what we call it as the energy graph. You see, this is the energy graph. This is the kinetic energy, and this is the potential energy, and this is the total energy. Energy conservation. Total energy remains constant throughout the motion. Energy transformation. Energy continuously transforms between kinetic and potential forms. Amplitude dependence. The maximum value of kinetic and potential equals to the total energy half k a square. Maximum and minimum. K is maximum at x equilibrium, and u is maximum at x plus minus a extreme position. Intersection. K is equal to u at x equal to plus minus a by root 2. This is the intersection, right? So intersection k equal to u at x equal to plus minus a by root 2. And you see the simple pendulum. Construction a point mass bob suspended by massless string of length capital L. Force, tension T and gravity mg. These two forces are acting. Assumption small angle approximation sin theta is equal to theta. And we know that the derivation, the period of simple pendulum is t equal to 2 pi root over L by g. Depends on length, it is directly proportional to root L. Depends on gravity, it is directly proportional to 1 by root g. And independent of mass, a heavy bob and a light bob swing at the same rate, independent of mass. And applications of oscillatory motions, timekeeping, inter-regular pendulum clocks and quartz watches, musical instrument, inter-regular sound production via vibrating strings or air, engineering, inter-regular shock absorbers for safety. And this is key summary and key formulas. Formula sheet, force equal to F equal to minus kx, total energy half k a square, b x equal x t equal a cos omega t plus phi, maximum velocity v max omega a, maximum acceleration omega square a. Pendulum period t equal to 2 pi root over L by g, spring period t equal to 2 pi root over m by k. And the rhythm of nature, from the atoms vibrating solids to the beating of human heart and the orbits of planets, oscillatory motion is the heartbeat of the universe. Thank you.